Section 6.1, the perpendicular and angle bisectors. So we've got 3 boxes here under the vocabulary. The first one is equidistant, and equidistant means equal distant. So 2 distances that are the same. So for example, let's say we had a line, and we had point A, and we had point B. They would be equidistant to the line if this distance and this distance were the same or were congruent. So equidistant is equal distant. It's what it is, the word breakdown. So we have the perpendicular bisector theorem and the converse of the perpendicular bisector theorem. So here's what it says. If you have a line segment, let's say AB, and you draw the perpendicular bisector. And we know it's a perpendicular bisector because of the 90-degree angle, and the 2 pieces are congruent. Then, every point on the perpendicular bisector, maybe this point right here, is equidistant to the endpoints A and B. So this distance and this distance are equal. Those 2 pieces are congruent. Now that works for every point. So it can be above, it could also be below, maybe here. This distance and this distance would be the same. Those need one more tick mark. So it works for every point. Now the converse says, if a point is equidistant from the endpoints A and B, then it is on the perpendicular bisector. So if they're on the perpendicular bisector, they are equidistant. And if they're equidistant, then they're on the perpendicular bisector. It goes both ways. The angle bisector theorem is a similar idea, but it's dealing with angle bisectors. If you have an angle and you have the bisector of the angle, and we know it's a bisector because the 2 parts of the angle are congruent, then what the angle bisector theorem says is that every point on the angle bisector is equidistant to the sides. And what that looks like is it looks like a 90-degree angle toward the side. And these 2 would be congruent to one another. The converse says if you put a point in the middle, in the interior of the angle, and it's equidistant to both sides, then it is on the angle bisector. So if these angles have the same measure, then these line segments have the same measure also. So example 1, find the indicated measure. And we are looking for AB. So look at this picture. What do we have? Well, we have a line segment BC, and then we have a 90-degree angle, and we know that these 2 pieces are congruent. They're both 6. So this line right here is the perpendicular bisector. And because that line is the perpendicular bisector, that means that A is equidistant to B and to C. So this length and this length are the same. So AB has to equal 9 because they have to be the same. 1B, find GH, this distance right here. Well, here we don't necessarily know that this is a perpendicular bisector. We know it's perpendicular because we have the 90-degree mark, but we don't know that it goes through the middle. So that's not where you start. Where you start is that these 2 are the same. F is equidistant to E and G. Because F is equidistant to E and G, that means this is the perpendicular bisector, which means those two pieces are congruent, so GH equals 3. Now I understand, example A and example B, a lot of students just look at it and they're like, yeah, the answer is 9, yeah, the answer is 3. And they don't necessarily know the thought process to get there. So it's important to me that you go through the thought process. This is a perpendicular bisector, which means those are equal. This does not say perpendicular bisector, but it has to be perpendicular bisector because F is equidistant to E and G. For C, what do we have? We know it's perpendicular. We don't necessarily know that it's a bisector, but what we do know is R is equidistant to S and T. These numbers are the same. Those lengths are the same. And because those lengths are the same, line RU is the perpendicular bisector, which means this piece and this piece are congruent. And if they're congruent, that means they are equal, so set them equal. 2x plus 2 equals 3x. Subtract 2x, and you get 2 is equal to x. Now, before you jump on to the next example, please make sure you answer the question. We are looking for SU. So that means we have to take this 2 and plug it in. So 2 times 2 plus 2 is 4 plus 2, 6. SU is 6. Now technically you could plug it into the 2x plus 2, or you could plug it into the 3x, because we already said they're equal. It's also a really good way to check your answer, because if you plug it into one side and then you plug it into the other and you get different answers, then that means something had to have gone wrong. Example 2, find the indicated measure. Here, what do we have? We have two distances that are the same. So D is equidistant to C and B. This distance and that distance are the same because the pieces are marked congruent. What that means is we have an angle bisector. Those two angles here are the same. So that means this angle is 20 degrees. Now the question is the measure of angle CAB. Where is CAB? CAB is the big angle. So 20 plus 20, using the angle addition postulate. The measure of angle CAB is 40 degrees. Example 2b, find DC. What do we have here? We have, right here, an angle bisector. And we know it's an angle bisector because the two angles, the 30 and the 30, are congruent. And because the 30 and 30 are congruent, we know that the distance from D to B is the same as the distance from D to C. So DC equals 5. Part C, what do we have here? Look, we have an angle bisector. Here we're not actually told the numbers, but they do put the congruent symbols in there. So this is an angle bisector. And what that means is that the distance from B to D and the distance from D to C are the same. So set them equal. And solve. I'm going to add 1 to both sides. 3x plus 2 is equal to 5x. Subtract 3x from both sides. 2 is equal to 2x. Divide both sides by 2, and x equals 1. Now quick check, is that what was actually asked? No, they're asking for BD, so we need to plug it in. 3, so we're plugging it into BD. 3 times 1 plus 1 is equal to 3 plus 1, which is 4. BD is 4. All right, example 3. Slightly more difficult problem, but not impossible. This is a great multi-step problem to see if you can apply kind of everything that we've learned so far. So find the equation of the perpendicular bisector of AB. So there are two things going on here. It needs to be perpendicular and it needs to be a bisector. And the bisector means it goes through the middle. So A is the point 0, negative 2, and B is the point 2, 2. We need to find the midpoint. The middle of A and B is the midpoint. And remember the midpoint formula, x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So x1, 0 plus 2 divided by 2, y1 plus y2, negative 2 plus 2 divided by 2. Calculate the numerators first, following the order of operations. 0 plus 2 is 2. Negative 2 plus 2 is 0. And now divide. 1, 0 is the midpoint. So whatever equation we end up with has to go through the point 1, 0 because that's the midpoint. We also need to know perpendicular. Perpendicular means what? Perpendicular means the slope is opposite reciprocal. Now, from this point on, we've done problems like this. We did problems where you found the equation of parallel or perpendicular lines. The only issue is that we don't actually have the slope, so we need to calculate the slope. The slope formula is y2 minus y1 over x2 minus x1. So y2 minus y1, 2 minus negative 2 over x2 minus x1, 2 minus 0. 4 divided by 2, our slope is 2. So we want to use the opposite reciprocal of 2, which would be m equals negative 1/2. So now we have a point, we have the slope, we're going to use point slope. Y minus y1 equals m times x minus x1. So what's the y value of our point? 0. Our slope is negative 1/2. X minus the x value, 1. So y minus 0 is just y. And we'll have to distribute the negative 1/2, so it's negative 1/2 x plus 1/2. This is the equation of the perpendicular bisector. And you should now have enough information to complete your homework for section 6.1.